Hello guys, and welcome back to another video. Today I'm going to be explaining computer number systems and the different bases of a number and how to convert through them. So without any further ado, let's get started. Okay guys, so right here I have opened up Word and I create a new document, and this is what we're going to use in order to note down everything, write down so you can see. So I'm going to make it size 24 so you can easily see what we're writing on any platform, and we're going to also zoom in a bit. So let's do that, 20. Okay, so let's firstly discuss about the different bases of a number and what that means. So in base x, okay, so you're using a number in base x, you're going to have x possible digits to form a number with. So that means 0, 1, 2, and so on and so forth until you get to x minus 1. And those are all the digits you can use to form the number. And the numbers that you use every day are in base 10. They are decimal numbers. That's exactly what that means. They are decimal numbers. They are in base 10. So you could use 10 possible digits to actually form the number. So you could make any combination of these digits to form a number, and you can see there are 10 digits you could use. Base 10. So the computer has a processor that can transmit only two states by connectivity, that is either on or off. So that means you could use just 0 and 1. So that is a base 2 number that the computer uses. And what it does, it converts everything into base 2, performs the operations, and then converts it back and displays it to you. Now, the computer is not limited to these two bases. It could use any base, but the most common ones are decimal, the binary, which is base 2, octal, which is base 8, and hexadecimal, which is base 16. 5, 6, 7, 8, 9. Now you might ask, how do you put the digits from 10 to 15 without creating confusion? Because you can't use 10, 11, 12 because you're going to create a lot of confusion. So what you're going to do is use the letters of the alphabet, the first 6 letters of the alphabet, A, B, C, D, E, F, in order to note down the digits from 10 to 15. So these is how the number is being written. You can use any combination to form a number. Now, how do you know which one's which when you note it down? Well, there are two notations for this. So when you have a decimal number, base 10, you have your number like 2, 9, 6, 7, okay? And how do you know it's in base 10? You just put like this, and that you know this is base 10. The same with binary. So you have 1, 0, 1, 1, 0, and now you know this is base 2, this is binary because it has that little 2. The same with any other base. It applies also to octal, base 8, and with base 16. So you have 2, 4, 5, a 3, and this is a hexadecimal number, so you have a little 16 over here. But there are multiple notations you can use. There's one more notation. I don't really like using this one, but this you might have seen before. In Windows, when you get those errors like 0xC00000072, that is a hexadecimal number. So the number 245A3 in hexadecimal would be noted as 245A3, 0x245A3. So this means it is a hexadecimal number, and the number itself are just these ones, the ones after the x. This applies also to octal, so 0O, and you're going to have like 2, 3, 7, 6. You can't use larger digits, and then binary 0B, and you got like this. So we're going to use the same number right here. So this is going to be your little binary number, and the binary number itself is just everything after the B, and that's how you know that this is a binary number, and this is how you note them down. But let's go a bit to converting these numbers. So we're going to start by converting from a base to base 10. So we're going to convert, let's say, from binary to base 10. So this is pretty simple. So you got the number 1011. Let's use a simple number. And this is a binary number. and we're going to convert it into base 10. Now this is pretty simple. The first thing you have to do is start indexing your digits. So you start from right to left. So this is your first digit, this is your second digit, and you start indexing from 0. So this is digit number 0, this is digit number 1, this is digit number 2, and this is digit number 3. So let's start converting it. So you put the digit, so it's 1 times the base we're converting from, so this is 2, so we're going to put 2 because we're in base 2, and then we're going to put it at power 0 because it's the digit number 0 as we indexed it. Now the next digit is going to be also 1, and we're going to multiply it by 2 because this is the base that we're converting from, and then we're going to put it at power 1 because this is digit number 1 as we index it. Next, we have 0 times 2 at power 2 because this is digit number 2, and we're having it at power 2, and this is from base 2 to base 10. So we're doing that, and the last digit is 1 times 2 at power 3. And then you just make the operations. This is 1 because this is always 1. This is going to be 2, and this is going to be 8. So your number is going to be 11 in base 10. Pretty simple until now. And this applies to any other base. So the number A3 from base 16 would be 3 times 16 at power 0 because we are converting from base 16 to base 10, so we're 16. This is digit number 0, so we have power 0, and this is the digit itself that we're multiplying. So we're going to go ahead and do the next one, which is 10a, and we're going to put times 16 at power 1. 1, not tab, 1. Okay, and now you're just making these operations. This is 3 because anything at power 0 is always 1. So 3 plus 160. So this is 163. Okay, so yeah, and this is base 10. So this is how you basically convert from a certain base to base 10. So it's basically pretty simple. The next one is how to convert from base 10 to something. Now, the simplest thing to do would be this. So you have 12 in base 10. And usually when you have base 10, you don't write the base. So we're going to have it like that so it doesn't go over us. So what to do is divide by the base you're converting to. So we're converting to binary. So we're going to start dividing by 2. And this is going to be 6 remainder 0. Next, you got 6 because that's your result. You divide it by 2 because that's the base you're converting to. And so this is 3 remainder 0. Then you got 3. We're going to divide that by 2. That's going to be 1 remainder 1. And then 1 divided by 2 is going to be 0 remainder 1. And now because we got this to 0, we can stop dividing. So this is how you convert to a base. So we're converting to base 2, we're dividing by 2. Because we're converting to base 2, we're dividing by 2, and we stop when we get to 0. And now you can see the remainders are 0, 0, 1, 1. And if I put them down, it's 0, 0, 1, 1. These are the remainders. And your number will be the exact opposite. So if this is 0, 0, 1, 1, this is going to be 1, 1, 0, 0. If your remainders were 1, 0, 0, 1, 1, you're going to read your number from back to front, and it's going to be 1, 1, 0, 0, 1. You know, you just read the remainders from right to left. So your remainders are now 0, 0, 1, 1. So we're reading the remainders from right to left. So your number is 1, 1, 0, 0. Okay? And if you're converting, let's say, 12 to base 8, let's say we're converting to base 8, you're going to divide by 8. This is going to be 1 remainder 4. Okay? And then you got 1 divided by 8. And that's going to be 0 remainder 1. And now your remainders are 4, 1. And you're going to read them like this. And this is 14 in octal. So this is how you basically convert it. This is the classic method. But what I like to do, so let's say we're converting that 12 to binary again. Now, what we know from the conversion to base 10, you know what? I'm gonna leave this one, so you have to know this is what 100. But how do we convert 12 to binary without making these divisions? So 12, this is in base 10, and now what are we going to do? We're converting to base 2. So what is the largest the greatest power of 2 that will fit into 12? It's 2 at power 3. It's 8. So we got 4 remaining, and that's 2 at power 2. And what else do we got? Well, we got nothing else because this is already 12. So you got 12, and we're converting to base 2. So what's the greatest power of 2 that will fit into 12? It's 8. 2 at power 3. So then we subtract, and we got left 4. What's the greatest? It's 4. We're going to write that down. And now we got 0 remaining, so we could stop. So we're going to use the property that we used here to convert to base 10, and you will realize that this is actually 1 times this and 1 times this plus 0 times 2 at power 1 plus 0 times 2 at power 0. You know, you just do this, you get the greatest power, you again and again and again, and you keep subtracting until you get to 0. And then you write these powers down so it sums up your number, and then you do this, you get to write these down. And what you notice is that using the property we used last time, you noticed digit number 3 is 1, digit number 2 is 1, digit number 1 is 0, and digit number 0 is 0. You know, using the same property you used here, you just reverse it. For instance, we want to convert, let me think about a number for a second. We're going to convert 130 decimal into octal. So what is the greatest power of 8 that will fit into this? It's 8 at power 2. So that is going to be 64. So 8 at power 2. Now, what is the greatest power that fits? So we subtract 64 of this, and we are left with 66. So what's the greatest power? Yes, it is 8 at power 2. Again, so we already got 128 off of this 130. We got 2 left. Well, what is that power? Well, 8 at power 1, it's not going to fit because we have just 2. So it's going to be 8 at power 0. This is the greatest power that will fit. Plus, now we have 1 left, and that's going to be 8 at power 0. And now you get to write that down again, and you do, it's 2 times 8 at power 2 plus 0 times 8 at power 1 plus 2 times 8 at power 0. And you write that down. So you can see we got 2 times this and 2 times this. We put it down, and the 8 at power 1 is nothing. And now we write our number that we just obtained, and that's going to be digit number 2 is 2, digit number 1 is 0, and digit number 0 is 2. And it's 202 octal 130 in decimal. So we're going to go ahead here for a second and do that. So this is basically how you convert from a certain base to base 10 and vice versa. Now, how do you convert between octal, hex, and binary without actually going through base 10? And actually, you might not believe it, but it's the simplest thing to convert from, let's say, from binary to octal, from octal to hex. So first things first, you have to make a little table. So that's going to be 0, 0, 0. This is going to be 0, 0, 1, 0, 0, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So these are for octal. So you just keep incrementing by 1 and crossing orders, and you just got this little table, and this is going to be like this. This is going to be 0, wait, this is going to be 1, this is going to be 2, this is going to be 3, this is going to be 4, 5, 6, and 7. And now let's convert an octal number to binary and a binary number to octal. So how do we do that? So we have the number. What we put up before, we put 101, 110. So it's 101, 110, and let's add one more 1. Okay, so this is your little binary number that you want to convert to octal. So how do we do that? Well, 8 is 2 at power 3. So we group 3 bits, 3 bits, and 3 bits from right to left. But we don't have enough bits here, so we're going to fill that up. So now we can convert it. So we got 3 bits here, 3 bits here, and 3 bits here. So we grouped each 3 bits. Now look at your little table. So what is 0, 0, 1? So that's 1. What is 0, 1, 1? 0, 1, 1 is 3. So we're going to write down 3. Just a second. I should not put that. Okay. Now, what is 101? 101 is 5. And you're going to write that down. And this is your number in octal. Now, let's convert another number from octal to that. So we're going to give that 202 that we used before. How do you do that? Well, first things first, you're going to look at the table. What is 2? 2 is, no. Then what is 0? It's 0, 0, 0. Then what is 2 is 0, 1, 0. And now this is your number. This is your number. You could use it with the leading zeros, but just like in base 10, if you have in base 10 0, 15, you're not going to write the 0. You're going to write just 15. So this is the same thing in binary. You could just ignore the leading zeros, and this is your number in binary. Now, to base 16, to hex, is the kind of like the same thing. So you got 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1. We're going to go into the next column. And I'm going to go 0, 1, 1, 0. Then I'm going to go 0, 1, 1, 1. 1, 0, 0, 0. 1, 0, 0, 1. 1, 0, 1, 0. 1, 0, 1, 1. And then we're going to have 1, 1, 0, 0. 1, 1, 0, 1. Then 1, 1, 1, 0. And 1, 1, 1, 1. And this is your little tables, the same thing. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And you have to convert a hex number. And let's say you have to convert, let's say, from binary to hex. So we're going to have the same number. But this time, you are going to group 4 bits, not 3 bits like in octal, because this number, because 16 is 2 at power 4, so you're going to group 4 bits, and you're going to start this and this, and we're going to ignore the leading 0. Okay, and now our little number is 0101, which is 5, and 1101, I know it's 11. No, not 11, excuse me. It's, well, 13, I think. Because 12, yeah, it's 13. Didn't use, it's going to be 13, so in hex, that's going to be A, B, D. So it's going to be D, 5D in hex. So this is basically how I convert. I didn't use this table for a long time. I didn't, make conversions in the last month, and I kind of forgot the table. But if you do them often enough, you're gonna just know this flawlessly. You're gonna just know it if you're just using them. And for instance, let's give another number. So we're gonna put 1101, 100, 101. Okay, and what we're gonna do is just start grouping the 4 bits just like that. And these two are going to be considered to have leading zeros. So we're going to put leading zeros because it doesn't have. And what we're going to do now is put no color. No color, I said. Well, okay. And now what is this? So this is going to be 3. This is going to be 6. And this is going to be 5. So this is 365 in hex. Now, how do you convert from hex to binary? Well, it's actually you'll firstly convert from hex to binary. You just do the same thing. So you 458 from hex, and it's gonna be 4 is 0100. 5 is 0101, and 8 is 1000. So this is your binary number that will represent it. And how do you convert from octal to hex and vice versa? Well, let's say you want to convert 267 from octal to hex. Now, what do you do first? Well, you write them down in binary. So that's going to be 010, then it's going to be 110, and the 7 is going to be 111. And we're going to start grouping them 4 bits. I'm just putting these highlights so you can better see. We're going to group 4 bits and 4 bits. So we get our number. And 1011 is 11, so that's going to be B. And 111 is 7 also. And this is your number in base 16. And the same thing vice versa. So let's say we want to convert AF from hex to octal. So what you do is just write this is 1010 and F is 1111, and this is your binary number, and you convert it to octal. So this is fairly simple. You just group 3 bits, then you group 3 more bits, and you put 3 more bits. We're going to put a leading 0 here, and we're going to group 3 more bits, and 010 is 2, 101 is 5, and 111 is 7, and you're going to just write that down like this, and your number is 257 right now in octal. So this is basically how you convert from different bases into each other, how you convert from base 10 to base 8 to base 2 to base 16, and in between those. So this is basically how the computer number system works. It uses base 2, 8, 10, and 16. So yeah guys, thank you for watching. If you enjoyed this video, give it a thumbs up. If you didn't, give it a thumbs down. And if you want to see more, click that subscribe button with that little bell to get notified every time I upload a new video. So see you next time on HowToIT.